Solving logarithmic equations, we'll look at two examples. First, we'll solve log of 2x plus 1 equals 3. Now, to solve this, we're going to use a very special property of logs, and it is that if you have a to the log base a of something, that's just equal to the something, or m in this case. This is because a to the x and log base a of x are inverse functions. So basically right here I'm just composing two inverse functions, so whatever the input is, it comes right back out. Now in this case, we're working with a log base 10, and so you would see this property written as 10 to the log of m equals m, where I don't actually write the base of 10 right here because it's a log base 10. How do we take advantage of this? Well, I can actually make this log go away using this property. So if the left-hand side equals the right-hand side, then if we put 10 in the base of both of these, in other words, if I do 10 to the log of 2x plus 1, that should be equal to 10 to the 3, because the exponents are equal to each other and the bases are equal to each other. But on the left, using this property of logs over on the right, we get the log and the 10 to cancel away, and we get 2x plus 1 on the left by itself, where 10 to the 3 is 1,000, so I've written that out. From here, we can really easily solve for x. So I can subtract 1 from both sides to get 1,000 minus 1, or 999. And then I can divide by 2 on both sides. So general strategy is whatever type of log you see, this is a log base 10, put whatever the base is as the base of both sides of the two things that are equal. Okay, let's look at a second example. We want to solve 9 over 7 log base 3 of x equals negative 5. Okay, now we're going to use a similar strategy. The only thing is that we cannot start by doing 3 to the 9 over 7 log base 3 of x equals 3 to the negative 5. And here's why. We will not get this stuff to cancel away. So if we try to cancel here, it doesn't actually cancel because of this 9 over 7 that's in the way. So in the way. We do have that 3 to the log base 3 of something is equal to that something, but we're not allowed to have something like in front of the log. So instead of immediately putting 3 as the base of both sides of this, I'm going to multiply both sides by 7 over 9. So I'm going to start by taking my equation and multiplying both sides by 7 over 9 so that I can isolate the log portion of this. So I'm trying to get the log base 3 of x by itself before I do something else. Okay, so once I've isolated the log, I'm going to notice that this is a log base 3. So I'm going to put 3 as the base of both sides of these things that are equal to each other. So I put 3 as the base on both sides. Now, what's the purpose of putting 3 as the base on both sides? Because now, right here, 3 to the log base 3 of x is just equal to x. So it's a way of getting rid of the log. And that is equal to 3 to the negative 35 over 9. Now that's a kind of strange number, so what I'm going to do is I'm going to type it into my calculator to get a rounded answer. And if you do that, you should get 0.0139.